The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome to the second of today's webinars from Smart Vision Europe. And this time we're talking about using predictive analytics to maximize the value of charity donors. And my name is Jonathan Quinn. I'm joined online today by my colleague Rachel. If you haven't encountered Smart Vision before, you haven't come on any of these web sessions, just a few housekeeping questions I'd like to deal with at the start, which is the fact that we do record these webinars, so you'll be able to listen to it again afterwards if you find that useful. Secondly, we email out a PDF copy to you of the slides we're using today after the session is ended. And if you think it's useful for your colleagues, we may be able to arrange a private webinar to rerun it. If that's useful, just ask us. With regard to asking questions, actually, all the lines are muted, as you heard at the start. So we ask you to use the chat facility. If we run out of time or unable to answer your question, we'll follow up with you offline afterwards. But in the meantime, Rachel will field the questions as we're going along. So if you don't know who Smart Vision are, we are a technology company and we specialize in predictive analytics and advanced analytics. We're a key partner to IBM and to SAS, and we're also an exclusive partner for a little company called Blue Sky Statistics, who provide an R-based statistical analysis tools. And we're veterans of the analytical industry. Each of the team members have at least 15 to 25 years of experience working in advanced and predictive analytics. And I personally have worked for SPSS for many years and IBM and SAS as well, if you're familiar with those organizations. So we normally start the section by talking about what we mean by predictive analytics. I think actually Wikipedia have updated this definition. This looks like an old definition to me, but it hasn't changed that much. In both of the definitions, it pretty much says that predictive analytics is a group of different, a smorgasbord, if you like, a variety of different techniques, all within analytics. So statistics and data mining. Here, it's this statistics and data mining. I think in the latest definition, it talks about a variety of statistical techniques, including machine learning, for example, and predictive modeling. And it says, in both occasions, it says it analyzes current and historical data to make predictions about future events. So what you take from that definition, which is a reasonable stab at it, is predictive analytics encompasses different types of advanced analytics, including statistics and data mining, and as we see in the later definitions, machine learning, predictive modeling, etc., etc. So that tells you that it's a banner term, basically. It's a banner term that uses, that's there to encompass different techniques, different traditions. And IBM tend to approach it from the standpoint of structured and unstructured data. So structured data is the sort of numerical, quantitative data that we're used to dealing with in statistics. Unstructured includes text-based data, verbatim text, social media, video, audio, images, physical images. And of course, that's a burgeoning and growing area within the big data realm. So vast amount of that type of unstructured data that's growing. And you may read things in the newspaper about how machine learning techniques are used to do facial recognition and stuff like that, and to classify and categorize people. So IBM kind of talks about that and says that, it's that type of data with mining, predictive modeling, and what we call scenario what-if analysis, which we'll come again to later. I think in both situations here, it's hard to come up with a single snappy definition of predictive analytics, which is why at Smart Vision we tend to break it down into different bullet points to make. So the first thing we say is that predictive analytics is not like business intelligence or AMI, management information reporting. It's different from that. It's not so much focused on simply describing variation and reporting that back. It's actually also not always about prediction, which is ironic given the title. A lot of the times predictive analytics includes things like anomaly detection, where you're looking for unusual events, not really making predictions. Or very importantly, of course, within the charity sector, it involves things like segmentation or cluster analysis, where you group similar supporters or donors together to try to characterize them better and interact with them more appropriately. But one of the things that makes predictive analytics different from BI or MI is that it does create important new data. So it's always creating something that didn't exist before, a new column of information. And these data take the form of an estimate, a likelihood, a probability, a forecast, a recommendation, a propensity score, a classification, a likelihood value, whatever you want to call it, a categorization. It could be a string, it could be a description, or it could be a number. A number might be a percentage, or it might be a decimal place, it might be an integer. So, you know, it can take many different forms, but the point about these numbers is they help us to make a better decision. And the predictive analytics application, or the model, is creating these numbers based upon historical data and the pattern that is uncovered. So one of the things we ask ourselves is, what do you do with these numbers once you've created them? What is it that, you know, good predictive analytics applications actually do? Well, believe it or not, in a lot of cases, when you actually scratch the surface and you talk to organizations, you'll find that they don't do anything with it. Very often they're just using the predictive model as a sophisticated form of BI, as a way to interpret or understand what's happening. But they're not necessarily doing anything with the predictions. Those people and those organizations actually act on the predictions themselves. Well, they tend to send these out into operational systems. They take these numbers, these categories, these new values, and they send them into an operational system. Now, an operational system, in the case of charities, is usually something like a campaign management system, where we're saying, okay, these are the people that you really need to concentrate on, given your limited resources, your limited budget for this campaign or for this interaction. It may be, alternatively, it's being sent out into a website management system. So it might be saying, okay, the next time this person or people like this come on or you know, interact with our website, or they enter a particular search term, or we recognize a certain cookie, this is the content you should be showing them, because it's the most relevant and the one which is most likely to, you know, prompt them to make a donation or to interact with us in some way, or sign up to become a supporter. But the other area that people often don't think about is, given that these numbers, these values that you're creating are valuable, maybe we should be sending them back out into, you know, our existing insight systems. Most organizations don't have predictive analytics, despite the fact that it's talked about so much. But they all tend to have some sort of BI or reporting function. It might be something as simple as Excel, or maybe something more sophisticated like Tableau or Business Objects or Cognos or something like that. But they tend to have something like that. And what they're doing there, of course, is they're reporting on variation. They're reporting on things which are important to them, whether it be donor attrition or latest revenue, or, you know, the number of sign-ups or interactions or supporters that took part in a particular event, or the number of events that are running, or something like that. And because that information is important and it varies, they tend to report on it. In the same sense, the probabilities and estimates themselves, and very often the success of the models and the degree to which they're helping or making a difference, they're also worthy of reporting on. And one of the big advantages of that is that you're exposing the work that the predictive analytics is doing to decision makers, people who are often in senior positions. One of the problems with, you know, machine learning teams, data scientists, predictive analysts, that type of stuff, is that they're often hidden away and they're in quite technical roles, and it's not always clear to the executive what they're doing. And this is true in not-for-profit as much as it is in for-profit. So this is a nice way that if you have somebody who's working within predictive analytics, or they're building a model and producing scores, you should think about integrating those scores, or sending those scores back out into a BI system, which shouldn't be too difficult to do at all, actually, because there are a lot of benefits of that. Okay, so we think about core applications within charity analytics. Think about where people are actually using predictive analytics. Well, there are three classic areas. One is to acquire more supporters, to acquire more donors. So understanding who your best potential supporters are, what are their demographics, what are the people with the longest lifetime value. Can we predict them early on? Can we predict people from a certain point? Can we associate certain geo-demographics with certain types of donor behavior? Can we figure out how to connect with them in the right ways? Can we look at different channels? Historically, what sort of approaches have we used? What has worked? Where are the exceptions to the rule? Can we predict who's most likely to convert? given the things that they're searching for, even if we don't know who they are, when they're coming onto the website and they're searching around and they're looking on the website, can we tell from the way in which they're interacting with it whether or not they're actually likely to make a donation? Or we're trying to grow the relationship, we're trying to understand the best mix of things needed by your supporters, beneficiaries, and channels, trying to maximize the gift value received through your donors and channels. What are the messaging that you interact with them with? Who are the people you should be concentrating on? And taking the best action every time to interact with them, given the fact that they all have different needs and they have different reasons, different stories for being there in the first place. And then, of course, there's retention. Supporter retention. Unlike a mobile phone company, it's not always clear when somebody stops being a donor or a supporter. They simply stop supporting us, unless, of course, they cancel a direct debit or something like that. Then that's a much harder outcome, and we don't hear from them again. But usually you can come up with some sort of definition and say, well, if we haven't had a donation from this person over a certain period of time, or if they cancel a direct debit, then chances are that they are lapsing, or they're not engaging with us, and they have effectively churned at that point. And this is a classic area within predictive analytics, predicting who is likely to churn, who is likely to stop donating, so that you can interact with them in advance of that occurring, and hopefully persuade them to remain with you. Now, with something like charities, it's critically important to do that, of course, but it's also something where that interaction may have a cost associated with it. You can't interact with everybody all the time. You can't necessarily try and persuade everybody to keep on board all the time. So being able to predict those who are valuable and who are likely to no longer donate up front is very, very compelling. Keeping your best donors on board, taking the optional action to retain their support. All of these are potential areas where predictive analytics may be brought to bear. Now, when you think about analytics generally, there's a lot of technical jargon out there. There's a lot of stuff around analytics in business applications. Business applications are always talking about propensity modeling and something called net promoter score. We talk about cross-channel and lift modeling and all these sorts of stuff. So the point about this stuff is that it kind of gets in the way of understanding the reality of predictive analytics. So a lot of the terminology gets in the way of understanding the reality. The reality is that it's fairly straightforward to build models. That's the first thing. Okay, there might be good models and there might be bad models, but it's very easy to actually build one. Okay, so you need to kind of forget about that to a degree. Models that are easy to build are very often ones which are hard to make decisions with. So when you build a predictive model, or you use predictive analytics to build a model, you must think very carefully before you even start the process of saying, well, if this was a good model by whatever criteria I have, it's accurate, it makes sense, it's simple, it applies to a wide number, a large number of our business. What would we do differently, and how would we measure the effect of it? These are the key questions, not all of the sort of jargon around it, really focusing on what we would do differently. So when we think about the different types of models that are out there, different approaches, we can actually break them down into about 4 different families. And one is a classification of propensity, and this is basically, it means an estimation model. It means a prediction. It says, this is where it predicts who is most likely to respond to a campaign, who is most likely to convert to becoming a supporter after interacting, who is most likely to lapse based on historical response data. What is the array of behavioral data we have about them? It could also be a number. It could be, what is the average donor lifetime we can expect from this person, given that we've got 3 months worth of data on them? Can we actually estimate the value? Can we estimate what the maximum or minimum is that they're going to donate? Can we estimate, can we tell, how many people they're likely to recommend, the many people are likely to contact or draw upon support for an event, let's say. And then you have clustering. We have things like, how can I divide my supporter base into meaningful and usable groups as a framework for communication? Now, very often, businesses and charities, with profit and not for profit, they already have something like a segment. They talk about their donor segments and segmentation, that type of thing. This is when we, as a business or as an organization, from a top-down standpoint, decide these people belong to this segment, these people belong to that segment. Okay. When we do predictive analytics segmentation, what we're doing is we're saying we're looking at the data, and we're saying the data will tell us what segments we have. The data will actually tell us that it can see 6 different groups here, and it's clustered them together into these little groups, and we can then say, well, because the data is clustered them together in these different groups, we should treat them as if they're actual groups, actual segments within our donor base. We have things like association and sequence. And basically, association and sequence means looking at things that tend to co-occur. So it could be combination of events. People who do this event will also do this, or people who donate through this channel will often also act in this way. So it's used a lot in retail where they find out what products people purchase together, for example. But sequence is similar to that. Sequence is saying, well, okay, what order do people do things in? Is that important? So if it is important and it finds a rule where the order is important, it will say, you know, if somebody, I don't know, starts off by sponsoring an individual in an event, then 20% of the time they'll do this next thing. This will be the next thing, or 30% of the time they'll do this next thing. So sequence analysis, again, slightly different from classic prediction and different from clustering. And then last we have time series. Time series just means forecasting, and that means looking at revenue, looking at supporter sign-up relationships. It's looking at sponsorship. It's looking at a number that varies, a trend over time. And the trend might be broken down into different regions. It might be broken down into the revenue of different shops or different stores. It could be broken down by segment, by age group, by supporter type, by cause. You know, there's lots of different ways in which we can take a series of value and break it down. Time series analysis simply looks at that series over time and then automatically forecasts into the future and says, okay, this is what we think they're going to make next week, next month, next year, or this is what we think the sign-up's going to be, or this is what we think that the bump around Christmas is going to generate this year, given the previous 4 years of data and given the marketing spend that we're planning for this particular event that we've got coming up around Christmas. So time series is really about extrapolation, if you like, extrapolation of a trend. So typical charity applications, things like, of course, recruitment profiling, trying to say, well, this is the profile of our ideal supporter. It could be a segmentation, it could be a data-driven supporter segmentation where we try to say, okay, these are the segments that we can see within the data. It could be supporter life stage modeling, saying, well, look, we need to be able to get this person to this stage next. There's an X% chance of them being in that. Or if we offer this or we do interact with them in this way, it will increase the likelihood of them getting to stage 3 or whatever of our existing life stage model by Y% or something like that. Okay, so let's take a really simple one. Let's take something like a campaign response or model, something like that. So our reactivation model or legacy propensity model or yield model or something like that. And the reason why these are simple is because they have a hard outcome associated with them. We have historical data, and we have data about supporters and who has responded to a campaign and who hasn't. We have attempts to reactivate previous customers, or they've lapsed, supporters that have lapsed, and we've sent out follow-up mailings, and it turns out a small percentage of them have actually signed up again. What is the difference between them and the people who didn't sign up? And then we have legacy, people who've actually included the charity in a legacy donation. What is different about those sorts of people? So this hard outcome means that, okay, we can't necessarily, of course, just send out content, whether it be in physical mail, physical letter, or an email. We can't just send it to everybody, because we have, you know, and classically within marketing, you have things like customers. You have people who are no longer customers because unfortunately they're deceased, or they've said don't contact me, or they're no longer supporters in this case. And then you might have some campaign selection rules, like they've only just recently become a supporter, so you know they're not eligible for it, or maybe you're offering something, some sort of reward, and you say, okay, well, you know, in this case it was no discount, but it'd be like no offer for this person because they're quite, you know, quite low yield. which means that you end up with this potential pool of individuals who may or may not respond to this interaction, this reactivation, this campaign response. And all the model that you're doing, that you've created, is that it's acting as another filter, and it's saying, well, off the potential pool, once you've taken out everybody from the campaign, everybody who isn't appropriate for it, this is the score of each individual and their likelihood to respond. And all you do is you simply select the X amount of people that you want, and it's usually up to the size of the campaign, with the highest scores, of course. So the goal of the model is then to drop people who have a low likelihood of responding to it. Now, it might be that you do something clever. It might be that you take the likelihood of responding and you multiply it by, previous people's, average donation. So you take into consideration their donation, and you optimize it in that way, you rank them in that way. There's lots of different ways in which you can do it. You could rank them, multiply it by their recency score or something like that. But ultimately, this model is simply going to give you a number. We're talking about these numbers, these recommendations, these propensity values. And we should use that number sensibly to help us make a selection, to help us make a decision. Okay. Other charity applications, as I said earlier on, what-if analysis is really when we've built an application and we say, well, okay, well, what happens if we change it? What happens if we doubled, let's say, for a forecast? What happens if we doubled the marketing spend, the above-the-line marketing spend, let's say, for a particular Christmas campaign? What effect would that have? And you should be able to do that, because if you've got previous history of campaigns with different marketing spends each time, you should be able to predict that for every extra £10 spent, you get an extra Y amount of sign-up or Y amount of revenue that's brought in. So what-if analysis allows you to play around with those historical values to try and find an optimal outcome. You've got things like drivers of satisfaction. I mean, some people are satisfied with events and with interactions. You might be interested in that. Sentiment values analysis might be looking at certain events that are happening in the news. So you could be analyzing Twitter feeds and trying to classify and categorize what people are saying and what sorts of people are saying what things. So it may be about a particular cause or issue. You've obviously got things like recency, frequency, monitoring, so RFM analysis, social media analysis, web segmentation, what do people do when they come on the website. And then you've got beneficiary analytics, people who actually benefit in some way from the charity, understanding whether or not the needs or outcomes. So it's almost like patient outcome studies that people do in healthcare. If the charity is aligned to that sort of cause, you can literally say, well, what is the cost benefit of this? Or can we model it? Can we predict the outcome? Intervention analysis, when you have to intervene, when it is best to intervene, that type of stuff. Again, these sorts of things can yield themselves to predictive analytics, just as any other analytical application will. Okay, let's have a look at an example. So we're going to skip out here. We're going to look at a couple of little examples just to give you a sense of how these work. So I'm going to jump out to a tool here that we use for predictive analytics in Smart Vision. This is the IBM SPSS tool. And I'll do a really simple one to begin with. I'm just going to try and predict whether or not people respond to a campaign and give you a sense of how that would work. Okay, so if I just open up some work here, what we have is what's called a stream. And this stream is showing me connecting to some data. I'll just show you the data. These little circles here are data sources. Okay. Now, in fact, they're just two different tables within a database. So it's a marketing database, something like that. If I show you the top 10 rows of this table here, I'll just go and query that database and wake it up. So here we have things like we have the response, we have the cause, we have the time since last donation, time since first donation. So we've got some really basic data there in response. And then we've got information here about the gifts that have been made, the actual donations themselves. So we've got the total number, we've got the average, we've got the lifetime value, we've got the number of gifts categorized. So again, I've done work like this, as you'll see in one of the next examples, where I've looked at, for example, charity data, and I have counted or used this tool to create measures for me that count, for example, what the minimum and maximum donation was, how many times somebody changes the amount that they donate by, how many times somebody changes the method by which they donate by. And if you think that's probably not terribly interesting, it helps us distinguish a lot between people who perhaps are quite inert donors, who maybe just on direct debit and something like that. They're very profitable, of course, but they're fairly inert. They don't necessarily interact with the charity, and they're donating away, and it's the same amount using the same method. And they're very different, of course, from people who change the method and change the amount, and who change the channel through which they donate. So those sorts of numbers and those sorts of values, which again I would need to emphasize, you're probably not going to have in a database, but which we would create using an analytical tool. An analytical tool has to be able to create these measures, and when we create them, we end up with a wider data set here. So if I look at the preview here of this, I end up with 15 fields, and we've got this field here. Did they respond or not? Most people didn't respond, of course. Historically, within a campaign, you're going to get a fairly low response rate. If you got a 5% response rate, you'd probably be very happy with it. Here I've got 4,754 records, and I've got, you can see there's occasional response down here, and then no response, and it's groups of respondents, that type of stuff. So I've also got this field here called partition, which I'll come to in a moment. But basically, I've hidden some of the more ugly aspects of this because I don't really want to teach you how to use this software. But suffice to say, I'm doing a bit of preparation here. I'm preparing the data. And one of the things I'm doing is I'm breaking the data into two groups. I'm breaking it into what's called a test group and a training group. And what I want to do is I want to build a predictive model on one group, and and then test it and see how well it performs on a group that I've held back, just randomly split them into two groups, and seeing how well can the model guess the outcome, i.e. whether or not somebody responded or not, based upon a test group that it hasn't seen, that it hasn't been exposed to. And this is a standard approach. But of course, there are many, many different algorithms we could use when we're building models, and within this tool here, if I look at all these, look at these are all algorithms. These are all different methods and techniques, and it's bewildering. And then even within the databases themselves, these are different techniques within the databases. This is the techniques available within the TISA database. That's DB2, that's Microsoft Analytical Services, this is Infosphere, and there's Oracle. Look at all these different techniques. There's hundreds of them. And it's bewildering, particularly if you're new to this type of technology. Well, I did say at the start, you shouldn't worry too much about different techniques, really, because if it's a reasonable tool, you should just be able to link up one of these techniques to this data, and it will automatically try and build a model for them. And it turns out that certainly in these types, this is a classification problem, because we're trying to classify people into responders or no responders. If I look at the classification techniques down here, I could almost use any one of these. But it turns out I've got this technique called auto classifier, which I'm going to connect up here. And you can see here, it knows I'm trying to predict response because I've kind of told it that in the data prep bit here. This is my key field. And if I just show you where this is it's here on the auto classifier. And what that's going to do is it's going to try out lots of different algorithms. It's going to try out lots of different techniques to predict this response outcome. And it's going to choose the best three, choose the top three for me that it finds it's going to work with. Now I could get it to run 200 different types of models using different settings here. So I could really throw the book at it and just get it to churn away and try to find the absolutely the best model. And one of the dangers of that is that it will find a very good prediction. It'll find a very good pattern, a very strong pattern within the data. But it will just be luck. It'll just be luck. It'll be pure chance. So for that reason, we have a test group. And we say, well, okay, tell us how well you did on the test group. So on this occasion here, the predictive model, this auto classifier, which is going to try 8 different models, it will select the top 3 based upon their performance on the test group, on the group that we've held back, which is about half the data. So it's about 2,000 and something cases. And if I run it, it takes about 30 seconds to run because it's got 8 different models. You can see here it says it's going to build 8 models. I could have got it to build 18 or 81 or 800 potentially if I wanted to. It would just take a long time. And when it builds this model, it produces the model it shows me the model, not as a great big output window with lots and lots of statistics in it, but rather as a physical object. It says, here are the top 3 models, and I've encapsulated them within this, what we call a nugget, this object. And I can look inside this nugget and see why it has chosen the different models. So if I look inside, I'll right-click on it and say, edit the nugget, look inside it. And what we can see here is that it's choosing a model called C51, another one called Shade1, another one called CNR3. These are all what are called decision tree models. Okay, and we'll see why they're called decision tree in a moment. But I can also see from this how accurate the model is. I can actually see it. So if I double click on that little graph there, you can see this is what the model's doing. It's saying this is how many of the people who responded, and I've balanced the data so I have half and half in each group. I've just done some of the data prep here to try to get the same number of responders to non-responders. But it's saying this is how many of the responders I can correctly predict. This is the model prediction up here. So this blue group up here are the people that it has predicted to be responders, but they didn't respond. They didn't respond to the campaign, but it predicted them to be. In other words, that's the error in the model. That's telling me, how wrong it is, and this is telling me how right it is. And down here, it's saying for the non-responders, it's saying, well, some of them I predicted to be responders, but most of them I predicted to be non-responders. So ideally, we want a lot of blue in this group and a lot of green in this group. And of course, a model which is a little bit inaccurate, which is fairly reasonable. Of course, this is a very, very good model. What you need to be really suspicious of is when it's almost 100% accurate. When it's almost 100% accurate, it means there's something wrong. It means it's not a fair model. It's biased in some ways. So here it's telling me that it's 75% overall accuracy on the testing group. If I flip over to the training set, that was the group it actually built the model on. That's 50% of the data it built the model on. And we should expect to find, when we look at that, oh, look, it's 79% accurate. It's much more accurate on the training group. Well, 4% accurate. So we can flip back and forth between the training and the testing set. If we were to look inside one of these nuggets and see what it's actually physically doing, I could double click on this. And it shows me the model either as a series of rules. This is a rule that's found, or probably a little bit easier to get your head around, as what's called a decision tree. And it says, okay, if the data you give me, it was balanced to almost 50-50, and it says if you want to discriminate between people who are in the yellow group response versus the green group no response, it says that, well, if their donation value is less than 21, then none of them respond, basically. But if it's greater than 21, which is 2,000 cases, it says, oh, the response level is much higher. So it's finding me that the level of response for this group, assuming there was a 50-50 response, it's kind of balancing it out artificially. And it's saying, okay, but if the total value is greater than 333, then you get an even better response from that. And then it goes in and splits the total value against it. And if it was even better than 333, it was up to 1,000, then you'd find that it actually gets worse at 20%, but it's less than 1,000. And then you look at average order value and total number of gifts. And each time we're doing this, we're going into more smaller and smaller numbers of cases, but it's finding all the exceptions to the rule. And this is what a decision tree looks like. You start out with all the data, and it filters it down into the differences between the people who are not very likely to respond to the people who are very likely to respond as a series of rules. You can think of it almost like a filtration device, where hopefully you're going to end up with a lot of the yellows in some group and a lot of the greens in another group. All of these decision trees are kind of taking the same approach. This is a classic model. It works quite well. Here's another one here. Another decision tree is a different algorithm, but another decision tree is called a Triad decision tree. And there's another one there, which is a cart decision tree. There's slightly different algorithms, but they're aiming to get the same results. This is a very, very simple one. Look at that. It's a very simple one. So I mean, that's quite a strong contender. For example, it's really simple. It's only 68% accurate. It's really simple, and that's quite tempting, because analysts like really simple models. Anyway, if we want to evaluate this model, if we want to see how well this model works, we can either take all 3 models together and say, how accurate are you if I use all 3 of you? And To do that, all I do is leave this check with use. If I don't want to get rid of that one and just use the top two here, 70, 75%, I could just use those two. I switch them all on, then I could use them all. Now, how can you use them all? Well, if you think about it, every time a case is submitted to this model, it makes a prediction. And every time a case is submitted to this model, it makes a prediction. Every time a case is submitted to this model, it makes a prediction. Well, why don't we just take the majority, of votes, if you like? So it's like voting on an X factor panel, and it makes a vote on each case. It's a little bit more sophisticated than that. It actually uses what's called a weighted voting and looks at the accuracy of the model. But basically, these models are voting on a case-by-case basis, on a supporter-by-supporter basis, as to whether or not they think they're going to respond to this, to a forthcoming campaign. If we see how accurate that is, I can attach this little node, say, tell me how accurate that is. And it shows me in terms of the testing group and the training group. It says, in the training group, if you're using all three of them, you'd be 74% accurate overall. In the testing group, you'd actually be about 74% accurate overall if you were using the training group. This group here is, this table down here shows me the level of accuracy I would get on the testing group. That's the one I should really focus on because that's the fair test. And it's saying, well, if you were using this in anger, you would end up mailing about 1,200 people. About 1,214 people, of which 308 would actually be non-respondents, 909. You would also be missing 300 responders because you wouldn't mail them based upon this prediction, because this prediction here is saying, I don't think these people are responders. How is it doing that? Where is it coming from? Where's these numbers? Where are these predictions coming from? Well, the predictions are coming from these new numbers that the model creates. Of course, the model creates new numbers for us, and if we look at the new numbers that the model creates, here they are at the end, and this is the prediction. It predicts it to be non-responder, non-responder, responder, non-responder, 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 responder. So it's predicting people to be a responder or non-responder based upon where they lie within that pattern, and it gives me a confidence for that prediction. And it turns out that, if they're more likely than not to be a responder, then it says, it's okay, they're going to respond. If they're more likely not to be a non-responder, it says, okay, they're going to be a non-responder. So that threshold, that number, the higher the number is for either of those groups, the more confident it is of its prediction. And in fact, we can even graph this. We can have a little chart here. If we run this little chart shows me, for the people who respond, both the performance of the model on training and testing. Well, let's just ignore the training because that's kind of the training group. Let's look at the test group here. And we have 3 lines inside it. And the variable that's being shown here is called $XF. That means it's an ensemble model. That means it's using all 3 algorithms. And it's saying that if you were to take an average, if you take a random approach, if you just take a completely random approach to this and saying, okay, I want to guess whether or not somebody's going to be a responder or not, then you could only find, the gain is the number of responders, you could only find 50% of the responders from 50% of the data, irrespective of how many responders there are, because you're just randomly doing it. You'd find 25% of the responders from 25% of the data. And that's why you get a straight red line. If, however, you had a perfect model, one where you were able to predict perfectly the outcome, then you would get 100% of the responders from 50% of the data because it's based on balanced data. So that's telling me what a perfect model would look like. But the green line is our actual ensemble model, our combination of models. And it's saying, well, I can get you 74% of the responders from 50% of the data. So that tells me how much better it is than random and how much worse it is than perfect. In fact, we could go back to this little nugget here and say, okay, generate an evaluation chart, and show me the charts for the individual models here. The individual models, look at that. These are the individual. This is the C5. This is the blue one. This is the green one is the shade model, and the orange is the cart model, and this is the overall one. And basically, if we take the votes of all of these models and combine them all together, we get this overall single green line here. Okay. So I can pick up one of these models. I can say, actually, you know what? I don't want to use all 3 of them because that's too complicated. I'll just double click on that one. And I'll say, just generate that one for me. This is the best one. That's good enough for me. And you call it generate the palette. You can see it flashing here in the corner, and there's that model. So I can pick that model up and I can apply it to new data, and it will produce these numbers again, these predictions for me. I won't call them $XF, it'll call them $C because it's C5. And all I need to have is the same data that I built the model on, so historical data, but of course I won't know the outcome because we haven't offered them. We haven't sent the offer out to them. We don't know the outcome. So there'll be no response field when I attach this model to it. So when I go to do that, I can open up another screen here. Let me just switch this off a second. Here we have the supporter scoring. So let me see if this works. I'll hit preview up here. So this is an autumn campaign that we've got coming up here, and we've got a big bunch of customers or first people that we show the top 10 rows here. And what we see is that we've got no information with regard to the outcome of whether or not they responded, because the model has to produce that. So when we look at what the model's physically going to produce, the model produces this prediction for me as to whether or not they're likely to respond. So 10% means only 10% chance they're going to respond. Okay. And then I can filter out all the fields I don't want, because I'm just going to send out the account number, the donor number, and this response propensity value, which is really just the old number here, which I've renamed. And I'll end up with a table showing me the people we're going to use in the selection here. And it says, okay, here are the people with a really high likelihood to respond, going from top to bottom. Okay, so these are the numbers you should need to be hitting. And all I've done is I've selected in there those with a very high response propensity, those with more than 60%. And it sends that table out into a database called Autumn Campaign. And that database, of course, would then be used. It's actually just a table in the database called Autumn Campaign. And that table then could be used by the marketing department to select the best customers or donors for the campaign. So that's the essence of it. The essence is we build the model using historical data with known outcomes. We pick the best model that we think we can get out of that. We copy and paste it down to a new selection of data where these are the candidates for the campaign. It produces its predictions, and we simply then get rid of anybody who has a low likelihood of responding. That is the business of what's called scoring the data. Just a little example there. So this is predictive modeling. What about something different? What about something like cluster analysis or something like that, where we're not trying to predict it? This is something which is, of course, very widely used. So we've got some data here. We've got some charity data, and we've got information. Together the customers. If I double click or the donors, if I double click on that, we can see that it says, well, it's a reasonable cluster quality. We can see that one of the cluster groups is quite small, only 3%. The largest one's 46%, next one's 20%. These are the relative sizes of the 5 clusters. If we look down inside the clusters themselves, we can start to figure out what makes them different from one another. And you can see the order is in order of the size. So it's saying cluster 3, cluster 2, cluster 1, cluster 4. We can call it segment 3, segment 2, segment 1, segment 5. I'm actually just going to resort it so it's in numerical order. So there's 1, 2, 3, 4, 5. And what we find is we start to look at it and say, well, what makes one special? Well, 81% of people in cluster group 1 are not in direct debit. So that's kind of potentially interesting. And they're all male. And they all donate through periodicals and affinity. And the number of transactions that they donate by is round about the middle here. This is the overall group here, but it's round about the average of five transactions that they've made. Cluster group 2 is where nobody is on direct debit, where it's also 100% male, where the main channel is mostly direct mail, more than it's mostly direct mail rather than periodicals and affinity. And the number of transactions is slightly less at 4.6. So they're quite similar, these groups. They're not radically different. Here's another one here where, again, nobody's on direct debit, but they're all female, and where the main channel is kind of split between direct mail and periodicals and affinity, and the number of transactions is, again, around about 5. Okay, so we've got some other values here, some other things we can look at. We can look at the amount donated and the tenure in months. As the color gets paler, it means that that field is less important. Less important. Here's cluster group 4. Everybody in cluster group 4 is on direct debit. They're mostly female, 60% female. They're kind of split fairly evenly between direct mail, periodicals, and affinity. Number of transactions is actually much higher at 9.48. And then last group here is probably the smallest group, is everybody is on direct debit. It's kind of split fairly evenly between male and female. The main channel is events and miscellaneous, and the number of transactions is massive. So this is a very extreme group here at 47, and they make a lot of changes to the amount and a lot of changes to the amount that they've donated, and the total donated is quite high. If we want to compare them all together, we can just double click on this. And there's no absolute right answer with cluster analysis, but certainly this gives us an idea. You can see this is called a cluster comparison chart, and it's saying, okay, here are all the people who are in cluster no direct debit versus they're in a direct debit. Here's the gender in which people are associated with gender. So cluster group 3 and cluster group 4, mostly female, dominated by female, was cluster group 1, 2, and the very small cluster group 5, dominated by male. Here you can see the difference in the number of transactions. So you can see that this median value here is 40. Everybody else is squeezed down the bottom. Method of payment is larger for cluster group 5. Here we have tenure in months. There's a lot of variation. The people who are the most recent is cluster group 2. The longest are cluster group 5. You could play around with this a little bit, maybe improve it, maybe try and figure out. There's other types of, here's one here with 10 clusters. Here's one here with 6 clusters. Maybe we could try and play around with that. Eventually, you're going to get to the point whereby you say, well, okay, I'm happy with the clustering that's doing here. It makes sense to me. Kmeans model, and I apply it to the data. What I end up is with this little node here where I can describe them, and I say, well, cluster group 1, I am calling 1 male cache readers. Cluster group 2, I'm calling core direct mailers. Cluster group 3, I'm calling bedrock female responders. Cluster group 4, high value direct debitors. Cluster group 5, super loyal direct debitors. So these are the sorts of descriptions one might make, and really you'd go to marketing to help with that. What's interesting is when we break that down by the last year of donation, last time we donated, and we're starting to see how the donor base is changing over time. So here we have 2011, and here's the breakdown here. If you can see that we've got high value direct debitors. The largest group is this female bedrock responders. One of the smallest groups is this group here, which is male cache readers. This group starts to shrink percentage-wise by 2012. They're getting smaller. This group is getting a little bit bigger. This group looks roughly, what's that, 20%? It's roughly the same. This group's grown from 9% to 12%. And then in the last one, in 2013, we start to see the emergence of the super loyal direct debitors. So these are people who are really, really loyal, and they're starting to emerge at this point. So the way in which cluster analysis and segmentation works is not simply just to tell you, this is what the world looks like now, but the fact that we can apply it back in time and say, well, look, if we were to take this cluster group here and apply it to some historical data, what would it look like? What would the breakdown look like? How is it changing over time? It gives us a sense of where the business is actually moving in future. So this is one of the reasons why segmentation work of this type, data-driven segmentation work of this type is so valuable to so many different organizations. Okay, that will give you an example. There's two examples. One was a predictive model. One was a non-predictive model, but rather a segmentation. How do our clients maximize success? What are the things that people who are, what's the sort of good practice, good advice, people who are good at this, what do? Well, the first thing that they do is they do not just leap in and start doing analysis. What they think about is they think about, how they're going to plan out the predictive analytics project that they're working on. They think about, what are we going to do differently? Why are we doing this? How are we going to measure the impact? What data do we have? And it turns out that there is a methodology that you can use that helps you plan out the whole process. And it really makes you stop thinking about algorithms and all that sort of stuff and really think about the practical, pragmatic side of it. It's called CRISP-DM. It stands for Cross Industry Standard Process for Data Mining. And it has its own website. So you can look it up and it will think of it as a roadmap and a way to have a common set of terminology and to plan out an engagement. So if anyone ever says to you, do you know how to do a predictive analytics project? The answer may be no, but it ought to be, well, I can find out pretty quick because there's a site called CRISP-DM that pretty much tells you how to do it. Okay? The other thing is that they don't just think about the transaction or gift data. They look a little bit further across the organization. They look at geodemographic data, descriptive data that they have. They look at interaction data, when somebody has actually interacted, when they've contacted or emailed the charity, when they have gone on the website, when they have called them up. And they look at attitudinal data, at social media data, if they can combine that in some way. So it may be that it's structured, maybe it's unstructured, maybe it's text-based. Text-based data, we can still make very good use of. We can use it to help enrich our models by identifying key terms that are used within that. And certainly the platform I've just shown you, which is the modeler platform, includes text analysis if you go for the premium version of it. The other thing, of course, is that they think about maximizing success by integrating the resultant insight that they're getting us with existing systems, whether it be BI reports, whether it be the database, donor management systems, segments that are going out there, campaign management, web channel, call center. The end point of the modeling process is not simply the model. You have to do something with the numbers that are coming out of it that are going to help you make a better decision. And in order to make a better decision, you usually have to send those numbers somewhere. Common misunderstandings are that your data is not going to be up to it. So particularly in charity, where they're not necessarily always very data rich, that really remains to be seen a lot of the time. You'd be surprised how much you can create from data, from existing data, like looking back in time and seeing how much that person has changed over time and measuring that, or how much the value has changed, or the type of method that they've used, that type of thing. So not necessarily an issue. The idea that you're going to need a PhD or be a data scientist, something like that, is not true. The algorithmic side of it's fairly small. It's much more practical in nature, much more about we are going to make decisions, we're going to do things differently as a result of this. What are we going to do? Why are we going to do that? And how are we going to measure the outcomes? Third, it's really expensive. That's a bit of a myth. It's not expensive to do advanced analytics. Some advanced analytics is actually free. You can get open source software to do that. The downside is that it's often more complex and requires a greater skill investment. And lastly, it's all about algorithms and things like that. Well, algorithms are fairly cheap. You can come by different algorithms. It's not about algorithms. It's about all the other things around that, everything else within the CRISP-DM process, if you like. So when we talk to people about advice to get started, we think about, well, think about where you'll get common analysis. analysis that you're doing. Consider a proven methodology. Christian is not the only one, but it's a pretty well-known one. That's a good one to get started with. Don't get hung up on modeling techniques, but rather focus on the business understanding phase of Christian and the deployment phase, the bit where you actually make a difference with the model. Consider the full data landscape. Consider the roles of people involved. Do IT have to get involved? Do marketing have to get involved? Do creatives have to get involved? Consider integration with other business insight systems. If you have already a BI platform, a support and management platform, for example, do you want to integrate these scores with them so that people can see the latest response likelihood for a particular donor? And focusing on how will you know it's worked, focusing on measuring the benefit, the response rate lift, the increased cross-sell, the revenue and profit impact. And lastly, check our website out. Our website has lots of video on it, lots of downloadable materials, blogs, etc., which go into this in a little bit more detail. So you get a chance to really have a bit of food for thought about how you might get started with developing your own predictive analytics function. Okay, lastly, working with us, well, you can buy software directly from us. And we do provide software itself, and we assist with pilot implementation and support of analytical tools, so you can buy our software online. And with regard to training and consulting, well, we do provide training and consulting. And we deliver classroom training or side-by-side training support, and even identification and recruitment of analytical skills in your organization. We help identify who the good people or the people with the potentially to become good analysts. And advice and support. We generally offer no strings advice, no strings attached advice, so you can just call us up and ask us. And we'll do our best to help you out. And we also offer technical support for existing users of software like SPSS and SAS. In the meantime, I hope you find that useful, and I hope that you log in again and check out some of the other web sessions that are coming up. In the meantime, have a great weekend, and we look forward to hearing from you again at some point in the future. Thank you. Bye-bye.